Good. Okay. Okay. So you can see my screen, right?
Yes, sir.
Oh. Okay. So let us complete our study of loops today, and then I will start a little bit on arrays. So loops. It's continued from the last class. So just as a recapitulation, we have seen while condition do body. So this while loop we have seen. Also we have seen for the for loop. So initialization portion, condition, and some preparation, increment portion, preparation for the next iteration, and then you have body. So these are examples of precondition loops. Which means before entering the loop, we check this condition C or C here. Now C provides one post condition loop. It's not that it's very important, but anyway this facility is there, so let us see. That is called the do loop. Do this body while condition is true. Okay. So once again, if this body consists of a single statement, I can avoid this and this. Okay. These curly brackets or braces. The difference between a precondition loop and a post-condition loop is that, first of all, I entered the loop for the first time without checking any condition. So the first entry in the loop is unconditional. Of course, only the first entry. After that, you want to re-enter the loop, you check the condition and then go back. So it's something like this. So you enter the loop body, B, then you check for the condition. If it is yes, go here. If it is no, move ahead. Okay. So you just keep it in mind that the first entry is unconditional. Okay. And of course, this syntax also seems to refer to that. First do this, then check the condition. If this is true, and then again go back and repeat. Okay. So I will give you a few examples to do some more stuff with loops and iterative programming. Suppose that the user enters some positive integer n. Okay. And you need to write a program which prints a diamond pattern like this. And so on. Okay. So it's something grows and then once again shrinks. This is the direction, this direction also. So this looks like a diamond, right? And let us do this. So this is something like this. And then maybe I have made it a little bit longer. So this kind of diamond I want to print. Okay, so let us do some mathematics. So if I want to print this pattern, so I have to fill this part with spaces. And also here. So the question is, how many spaces I print in the lines and how many stars I print in the lines. That I have to work out. So let us say this is line number. This one is line number 1. This one is line number 2. This one is line number 3. Eventually, I will have at the center line number n. This is dots. Okay. And that will have 2n minus 1 stars. So this is line number n. Okay. So that means I have a central star here and n minus 1 stars here, another n minus 1 stars here. Okay, so n minus 1 plus n minus 1 is 2n minus 2 plus 1 is 2n minus 1. For I equal to 1, okay. Then I have line something something, and here what? This is line 2n minus 1, 2n minus 2, 2n minus 3, and so on. But you see that this line is identical with this line. Okay, so I can also let a variable I run from 1 to n, then n minus 1, n minus 2, 2, 1, and this is 3, 2, 1. So this is 3, 2, 1. This way I can also write this code. So instead of using L, I will loop on some variable I, which increases from 1, goes to n, then it decreases, goes to 1, and then the loop breaks. Now, if I look at line number I, how many spaces I do have to print? Here, n minus 1 spaces. Here, how many spaces? N minus 2 spaces. So in general, when I has some value, I print n minus I spaces. So for this I, what I have to do, first print n minus I spaces. This is followed by 2i minus 1 stars. Agree? Line number 1, n minus 1, and then 2 times 1 minus 1, that is 1 star. Line number 2, n minus 2 spaces here, and then here, and then 2 times 2 minus 1, that is 3 stars. Okay. So with this mathematics, let me write a code for printing this diamond pattern. Let us call it diamond.c. So you start with the standard morning prayer, start your day. Then you go to your business, into main. Of course, don't forget to do this before ending. Okay, so I need n. User will give the value of n, and I also need this variable I. Okay, I possibly do not need anything else. Okay, so ask the user to enter the value of n and read it. Don't forget this and. So n now has a value. And of course, you can give a check if n is greater than or equal to 0. I want n to be positive. To give something. And here you may do this. Okay. Just exit. So this is just a sanity check. Okay. This is one way of doing it. Okay. Then I will write a do loop. Because n is now greater than 0, I will print at least once. So the first line I can print without checking any condition. Okay, so here I start with I equal to 1. Okay. I will actually use one flag. Okay, I will demonstrate two other things. Flag. So you see that in the first few iterations, I is increasing, and after it reaches n, it will be in a decreasing phase. So this flag.
So, just one thing to clarify: when it reaches the line number n, just one star it will print at the center, right?
If repeat the
So
question.
yes, according to that terminal, so if the pointer reaches the line number n, just one star at the middle is going to be printed.
Just this 2n minus no. This I have actually meant n minus 1 stars here. Okay, so here I just didn't print the stars, just to highlight how many stars should be printed. Actually stars. Okay.
Okay,
It's a square of stars. Okay. Okay, so now here I teach you one construct. This is what is called a macro. Okay, so hash define macro name. Okay, without any bracket or anything. Macro definition, and this is not followed by hash. Sorry, semicolon. Hash define macro name, macro definition. So here I have used two macros, increasing and decreasing. Increasing means +1 and decreasing means -1. Of course, I will actually use only increasing, or let us see. Okay. So here actually I am increasing this, I am defining this increasing macro to be a constant 1 and decreasing to be a macro which is a constant -1. Lots of other things you can do, but for the moment let us see how we can define constant values as macros. So there is a difference between macros and constant type of variables. These are not variables. Okay, So the difference is this. So initially the flag is increasing. Okay. So when I compile this code, there is something called a preprocessor. Whenever it sees a name like increasing, and it defines that this is to be substituted by 1. Okay. Likewise, this hash define things define this. Whenever it reads something decreasing, it replaces that thing -1. So there is a first pass of the preprocessor. Now when it finds here increasing, so it simply replaces that by 1. Okay. So there are other things you can do with macros, but for the moment, let us just see how we can use macros to define some constant values. You can actually define blocks here, and your parameters or your macros may be parameterized, but these are difficult things. Let us not worry too much about this. So I first set the flag to be increasing. Okay. Now, quite blindly, let me do this. n-1 spaces, 2i-1 starts. Okay. So, okay, here actually I need another loop variable j. So how many n-1? J equal to 1 through j equal to n-i plus j. These many spaces I print. And then I print 2i-1 stars. Okay. So if our maths is correct, this is the correct thing I am doing. J equal to 1, j less than equal to 2 star i-1 plus j. I will print the star. Okay. And then here, of course, there are several tips. Here itself, you can do a line break. Okay. Or you can print another n-1 spaces here so that it's actually a square matrix of characters. Anyway, so let me once again do it. Symmetric. Although this will be increasing. If you build a line break here, the effect will be the same as you print n-1 spaces. Okay. But anyway, let me do it. So this is the printing of a line. Then you go to the next line. Okay. Now I have to look at the value of I, and I have to find out whether I am in the increasing phase or in the decreasing phase. Based upon that, I will have to adjust the value of I. Okay. Let us see. If flag is increasing, and okay, if is increasing, okay, let us see. Else I will do something. Okay, so if I is 1 or 2 or 3, then I will simply keep on increasing the value of I. But if I is already equal to n, then I will not increase it. Instead, I will decrease it. Okay. So if I is less than n, I will keep on increasing I. Else, not only that, I has reached n, so I have printed the nth line. So henceforth, I will be in the decreasing mode. So I will just remember next time onward, I will be in the decreasing mode. Okay. And if I am already in the decreasing mode, I will simply decrease this. And how long will this go? You tell. What is the condition for breaking the loop? Starting from 1, I will go to end. Here I will switch from the increasing mode to the decreasing mode and keep on decreasing. And when will this loop stop?
I equal to 0 or I greater than 0.
Which one is correct? While I equal to 0 or I greater than 0?
I equal to 0.
No, this is not repeat until. This is do while. As long as this condition is true, this loop will run. So if I say I equal to 0, then this will break. For example, if I start with I equal to 5, yes, I equal to 5, I start with I equal to 1, then I go to I plus plus 2. If I say I equal to 0, then this will break in the first iteration, after the first iteration itself, right? So greater than 0 or I not equal to 0. So long as this condition is true, I will repeat. It is not that when this condition is true, I will break. That is not the case. Do you understand? So while I not equal to 0 or I greater than equal to 0, something like that. Or while I. Happy or not? Okay, so let us see. Let us run it. GCC minus wall diamond dot C. Okay. So I have to give a value of n. Maybe I give 10. That is like this. Why is there a? Oh, sorry. While I is greater than 0. So I can see a new line here. So that is not correct. So I greater than 0. Sorry. 10. Okay. Convinced this will work? And how does it work? Yeah, tell something. But if I give 0, of course, this is the initial message. If I give 1, it's just one line printed. If I give 2, something like this. 20, something like this. Okay. Maybe I can have a little bit more, 25, something like this. Okay, happy?
Yes, sir.
Okay. Okay, so you see that, of course, this is not a great example, but this is something which illustrates that this loop is executed at least once. In order to prevent that, I have to add this check. Okay, if n is less than equal to 0, then simply exit. Do not go here. Okay. So this is the diamond printer. Of course, if you want to look at little bit flatter, because you see this is the shape of a character in my window. So it's little, it's actually, I would say, the height is more than the width. Therefore, this does not look like a square. And if I want to make it look like a square, I can do this. Just use a space so that everything is doubled. Okay, so alert out maybe 10. Looks like this. Now if I compile and run with this, yeah, this looks better, right? Although this looks like a kite rather than a diamond, this is more a diamond-like thing. Anyway, let me restore the original version. No spaces. Let it look like whatever your terminal displays. Okay. Okay. Tell if I do need to explain anything more about this program.
So what is use of flag?
What is the use of flag? You look at this I. There is a phase initially where I keeps on increasing from 1 to 2, 2 to 3, 3 to 4 up to n. After that, I keeps on decreasing, n minus 1, n minus 2, n minus 3, and so on. Of course, there is a way you can do it by writing two different loops. One on I from 1 to n, and the second on I from n minus 1 down to 1. Okay. So I could write two different loops to handle the increasing part and the decreasing part. Okay, but in order that I can manage with only one loop, I have to somehow remember whether I am in the increasing phase or in the decreasing phase. So see here, I is 2 here, I is also 2 here. So by just looking at the value of I cannot decide whether I am in the increasing phase or in the decreasing phase. So this extra information is stored in flag. Initially, it is in the increasing mode. Whenever it reaches n, okay, I less than n, then plus plus I am still in the increasing mode. But whenever I reach I equal to n, then I go to the decreasing mode and keeps on decreasing minus minus I here or here. So that is how I am keeping track of in which mode I am. Okay. Clear or not?
Sir, what is I indicating here?
I is some variable I am using in my way. It's not exactly the line number.
No, sir. Here just like you, L is the line number. What is I?
I is something which is related to L, but not in an obvious way. Up to n, this is same. 1, 1, 2, 2, 3, 3, n. And after that, whenever I go to line number n plus 1, okay, I am using n minus 1 here. N plus 2, I am using n minus 2 here. Okay. The reason is that this line and this line, they are essentially the same. So although they are in different lines, I am using the same value of I. I is 1 here.
Is I also line number?
No, I is not line number. I is line number up to n. Okay. This is symmetric about this. If I draw a line here, this figure is symmetric about that line, right? Okay. So of course I
Yes,
could
sir.
have. Okay, of course I could have written so. If I have some variable I running through this part, I can reuse that variable to print this part. Okay, so that's what I have done. Of course, you can
Sir,
run.
for symmetricity, we have to use I.
No, of course you can write a loop on L. So that may be I leave it to an exercise.
Excuse me, sir.
Just let me finish. Do this using L. Okay, instead of I. Then you will understand the difference. Okay, using L as the loop variable, you print this. Okay, now tell your question.
So in the code, sir, if for third for loop, so if we did not write the third for loop,
Yeah, it will be its visual effect will be same. but I
Same.
will just give you this. So here I have printed spaces. Okay. And then at some point of time, this goes to the new line. Okay. If I do not use it, let us see what happens. Okay, you could see the spaces, right? Okay. Space, 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 space. You can see the spaces. Okay, so if I do not write this line, let us see the effect. Visual effect is exactly the same. Okay. But after star, whenever I want to go, I meet a new line. The spaces are not here. Okay, the visual effect is exactly the same, but there is no space here. So that's the difference. By printing these extra things, I am actually printing a square, although you cannot see it. Okay, but there is a space here, there is a space
Sir.
here, there is a space here, and so on. Yeah, tell.
Sir, in if condition, why did you use exit 1?
Could have used exit 0. Look, this is a difficult question. Why exit 1, not exit 0? If you have come here, I would consider that this is a normal termination. Right, what you are supposed to do, you have done, and you are now exiting. But if you exit here, it is a kind of abnormal termination. This is not what should have happened. Okay. Now you Unix and in C, 0 essentially means normal termination. 1 essentially means 1 or 2 or any non-zero value usually means a non-abnormal termination. Okay. So this is just a case of style. You could have written exit 0 here also. It doesn't matter. Okay. Okay. So what if we do if I do not use it at all?
Sir, can you say once again? I didn't hear. Hello, sir.
No. Exit. Whatever you are doing here, exit something inside this. This is what is called a status. Okay. 0 means normal termination. Non-zero usually means abnormal termination. Okay. So this is just a matter of style. Okay. You don't have to worry too much about it. You could have written exit 0 here. You could have written return here. Okay. But if
Sir,
I do
can
not.
you show full code?
What?
Sir, full screen.
Sir, if you don't
code.
use exit 1, then it will work.
It will work, but it will now try to execute this part. Let us see what happens. Let us see. Yes, it's an important thing. Okay, now if I give 10, there is nothing. But if I give 0, it will print something. Why? The first iteration it will print. Okay. If I give -5, then also it will print this. Okay. Because in do loops, the entry is the first entry is unconditional. So I cannot prevent the print of this line. Okay. So for that reason, I have put this. If the user supplies a value of n less than equal to 0, then I just print this diagnostic message and simply quit the program.
The same must have happened with exit 0.
What?
The same would have happened with exit 0.
Exit 0 has a similar effect, but it's 1 and 0. This is just, I told this is a matter of style.
Okay, sir, yes.
Okay. Instead of return 1 will also do exactly the same way. But there is a subtle difference. Let us not worry too much about it. Return 1 will work exactly in the same manner as exit 1. There is a difference, but let us not worry too much about this.
Sir, why there are two minus I in the else part of the code?
There are two else's, right?
Yes, sir. Oh,
Okay.
that is.
So this, look at this. When I equals n, when I is less than n, I am still in the increasing mode. From n minus 1, I increase to n. But as soon as this if condition is not satisfied, when I becomes equal to n, and when I becomes equal to n in the next phase, this is the beginning of the decreasing phase. So I am doing minus minus. But this thing happens, this entire part happens when I am in the increasing mode. This says keep on increasing, continue to stay in the increasing mode and keep on increasing. And this part says now switch to the decreasing mode and keep on decreasing. And this else means I am already in the decreasing mode, because flag equal to increasing is not true. So I am in the decreasing mode. Now keep on decreasing. N minus 1, n minus 2, n minus 3. Of course, n minus 1 is done here. Here. After that, n minus 2, n minus 3, n minus 4, 1. And eventually it will become 0. And then there will be exit or break. Okay.
Sir,
Sir,
you
can you
show
explain
full code?
flag part? I didn't understand that, sir.
No, why? I do not know. So first of all, the usefulness of flag, is it clear? By looking at the, because I am making a loop on I, not on L. Okay.
Yes, sir.
Therefore, if I has the value 2, I may be here, I may be here. There are two possibilities. I do not know if I am here. I is 2 here, I is also 2 here. Okay. So I do not know without a flag whether I am supposed to increment I or decrement I. Here I am increasing it to 3, here I am decreasing it to 1. Okay, so somehow I have to remember I am in the increasing mode of I or in the decreasing mode of I. Flag is precisely doing that. It is initialized to the increasing mode, and when I reaches n, it is switched to the decreasing mode. After that point onward, I will keep on decreasing I. Yes or no?
Yes, sir.
Okay. So I suggest that you carry out this exercise. Instead of using I, simply use this line number as the loop variable. Okay. So here the loop variable is I. So use L instead of I. Of course, this can be written, but the logic will be different slightly. Okay. So do it.
Excuse me, sir.
Again, yeah, tell.
Sir, can you show full code?
Full code you want to see. Oh, incidentally, this code will be uploaded to the course website. Go to my area, teachers area. I have already uploaded the previous codes. Some 2-3 codes that we have written. I will upload this. So you don't have to copy.
Sir, here has defined decreasing. It means decreasing has value -1 or it will decrease anything by -1.
Such as formal names. I could have given any name to this. Increasing and decreasing are two macros having the names. So one is a constant which is defined as the name increasing. Okay. I could have used any other values here, any other names here. This is just for readability. Initially, the flag is in the increasing mode, then it becomes decreasing. Yeah, tell.
So we can also use any different name for flag.
I can use any different name, any value. For example, I could have used something like this: 1000, 111, or -11. I could have used things like this. Anything.
No, sir.
Or
So I am asking that can we write any other name to flag? Means like we can use star or any other name for flag.
just a minute. Let us see what it does. It will do the same thing. Now, what is the question?
So can we write any different name for flag.
This name? Yeah,
Yes, sir.
it's just a name. Whatever name you write, it's okay.
Not at say increasing or decreasing. So I'm actually asking for flag. So actually, can we write star instead of flag?
This one. This is another variable. Any name you can give, whatever is allowed. This is a name, this is a name, this is a name. Any name that is allowed under C's convention you can write.
Okay.
Okay. So flag is typically, I would say, a common programming practice. Okay. Usually flag is often used as a Boolean value or something like that. Anyway, don't worry too much about it. Any name that is allowed in the scope of C, you can write. You can write F, you can write mode, anything, whatever is allowed. Okay. I won't believe it.
Sir, please check the chat once.
What?
Sir, we have posted a doubt.
What is the doubt? Well, when executing exit 1 star is printed. Yeah, 1 star is printed. Sir, why even after executing exit 1? No. After exit 1 star is not printed. Let's see. I actually demonstrated this entire 0. Okay, I am very angry, nothing is printed. If I just comment this is not there. I have commented this line. Now if I do it, it will print one line. Why? The reason is that it is a do loop, not a while loop. Okay. Therefore, the first entry is unconditional. And therefore, even if I do not want to print anything, okay, I am printing something. Because in the first iteration of this loop, the condition is not checked. Okay. So that's just the question.
Excuse me, sir.
Sir, in the first exit, if we use 0, will it work?
Yeah, it will work. You can
So
give any.
instead of exit 1, we write a whole loop in else statement, then it will also same.
What? Yes. That will also do. That is also fine. So you can say if n greater than less than equal to 0, I print if I am very angry, else this entire part. This will also go well. Exactly, perfectly well, no problem. Yeah, exit is supposed to terminate the program. Yes. Why even after executing the 1 star is printed? Now you see, if it is printed only if I comment it out. Yeah. Any other question unanswered?
Excuse me, sir.
Yeah.
Sir, I will ask in last.
Okay.
Some doubts.
Yeah. What is the doubt? Or is it done?
Yes. Sir, I will ask in the last.
Oh, in the end. Okay. We will do it. Okay, no problem. In the end, we will see. Okay, fine. Okay, so this example illustrates several things. First, the third construct of loops do. We can have loops inside loops, and also introduction to what is called macros. Okay, so macro essentially means literal substitution. Whenever your C compiler, the preprocessor, sees this name increasing, it will literally substitute this by 1. So it's effectively same as int nij flag equal to 1. Okay. Here also it sees increasing. It will simply replace this by 1 and this replace this by -1, and then it will compile. Okay. Anyway, let's not worry too much about macros. Let us have.
Sir, in the if statement, you have written flag is equal to 1, and in the else one you have written flag is equal to flag is equal to increasing. And in the else flag is equal to it decreasing.
Yeah, I'm setting it decreasing. This is equality check. This is assignment.
Okay. Okay.
Okay. Yeah, be careful. Do not confuse equal to with equal to equal to.
Sir,
Yeah.
sir, when you declare the flag, where you used increasing, why not decreasing?
Initially, what is this? Initially, this is the increasing mode, right? Why do I initialize to decreasing?
Okay, okay, sir.
Okay. Yeah. I think, yeah, you look at this code and try to understand how it is working. Let me proceed with other topics. Okay. Because I have to start array studio, otherwise you will be late for your labs. Okay. So we have seen something called break. Okay. So this essentially is something like this. Maybe you have a loop like while loop. This may be a while one loop or other loop. And then somewhere, maybe this is conditional, you write break. Okay, something. Maybe this may be conditional. Maybe conditional. If some condition holds, condition prime. Okay, it will break. So come here. Maybe you check whether the condition C prime holds, then break. Okay, something like this. If not, you will do this part. Once again, go to the top of the loop, check for this condition C, which may be 1, anyway, whatever it is. So there is, okay. And if this condition C prime is true, then irrespective of whether this condition C is true or not, it will come out here. Okay, we have seen an example here, right? Now, continue is a similar thing. So just write this, except that, then again, this may be conditional, this may be unconditional. We just write continue. Instead of break, I write continue. Okay. Yeah, just forget about exit 1, exit 0. If you do not understand, just forget it. Let's not worry about exit 0. Okay, this is not exactly a timely thing to work upon. Okay, just forget that. Okay, while C, this, and then maybe you are checking some condition, and then instead of break, I am writing continue. Okay, the difference is that if this condition C prime is true, then this loop will be broken. Here, it will not be broken. Instead, if this condition is true, then you will go to the top of the loop, ignoring the remaining part of the loop body. Okay, so let me explain it by an example. Maybe. Okay, so let us have some integer variable I. For I equal to 0, I less than, let's say, 100 plus I. printf I equal to %d. Okay. If I %10, continue, printf %t is a multiple of 10 I. Okay. So this will run, let us make it a little smaller. Instead of 100, let us have 32. Okay. So every time you will enter the loop, this will run from 0 to 31. As soon as I becomes 32, this will break. So 0 to 31. So it will print the value of I. Okay. And then if I %10, when is this condition true? I %10. Percent is the remainder operation. When is this true?
I is not taken.
When I is not a multiple of 10, right? So that the remainder is non-zero. Then I continue, then I do not come and print here. Okay, but if this condition is not satisfied, then definitely I will come here and print %d, I is a multiple of 10. So let us run it. Continue, right? Okay. So I equal to 0, 0 is a multiple of 10, I equal to 1, I equal to 2, I equal to 3. This part is not executed because I have given continue. Okay. So once again, when I becomes 10, it prints 10 is a multiple of 10. When it becomes 20, it prints it's a multiple of 20. 30, it says 30 is a multiple of 10, and so on. And then normally it breaks when I becomes equal to 32. Okay. So continue goes to the top of the loop. Okay.
Sir?
Yeah.
So continue is inside the parenthesis after if condition.
What is your question?
Sir, is the parenthesis modulus 10? Is it inside the curly braces? Continue.
You can write it because now because continue is a single statement, I can avoid this curly brackets or braces. Okay, because this is a single statement. But if you print it, if you enclose it within a pair of braces, no problem. This is also fine. This is also fine, no problem. Okay, but if you actually are using a single statement, there is no need for doing this. Okay. You can, this is like a normal if statement. Okay. You can write certain things here and then you save continue. Okay. If you use multiple statements, then you have to close this block within a pair of curly brackets. Otherwise, you can write a single statement. Okay. That's not an issue. Okay. So any questions on this concept? Continue and break.
Sir, in the command written, you in the if statement you have written I %10, I modulo 10. Sir, what is the meaning? Can you explain that once?
What is a condition in C? Tell, you tell. What is the condition in C? When is it true? When is it false? Any expression can be used as a Boolean variable. When the value is 0, it evaluates to false. If it evaluates to anything other than 0, any non-zero value, it evaluates to true. So this condition is true when the remainder of division of I by 10 is not 0. And it is false when the remainder of division of I by 10 is 0. Agree? And when the remainder is 0, it is a multiple, I is a multiple of 10. So I will come here, this will be bypassed. And I will come here and print. And if I is not a multiple of 10, this remainder will be non-zero. Then this print is skipped. Instead, we go to simply the top of the loop, the check condition, plus plus I and plus plus I and then I less than 32. Okay. Yes or no?
Yes, sir, clear.
I can use arithmetic expressions which has some value inside a condition. This is basically same as writing I percent 10 not equal to 0. This will also work equally well. Okay, but I do not require it. Okay. This is also fine. This will also work like this, exactly like that. Okay. But it's not, it's actually redundant. You can simply write I percent 10. Okay. Of course, if you think that this is not equal to 0 is more readable, go ahead, do that, no problem. The C compiler is not unhappy. Okay. Okay, so now there is a last question about this about this break and continue. So let's say while condition, and here you have while condition prime, they do something, and then you check if C double prime, then you write break or continue. Here you have something, here you have something, eventually this. Suppose this condition C double prime is true. Then you encounter a break statement. This will break which loop? This loop or both?
Sir, immediate outer loop.
Immediate the innermost loop. In which? So here this will be broken. The innermost loop containing break will be broken. So this is the rule you should keep in mind. So if I additionally want to break this loop, I have to write another break statement here. Okay. Okay. So if I write this way, in order to break both the loops, I need another break outside the inner loop.
Sir? Sir, does C support go-to statements?
It supports, but I will never teach you go-to, because all over the world, people have, I would say, discarded the use of go-to. It's deprecated. So I will not teach you, and I will instead teach you never to use go-to in your life. Okay, only this break, continue, these are kind of go-to statements, but otherwise never use go-to.
Excuse me, sir.
Yeah.
Sir, but if we do not use goto in C, there is no support for break outer statements. Like in Java, we have break outer. If we want to break from the outer loop, from the inner loop.
Yes,
but
sir.
C doesn't
Exactly.
support. So
Okay, no. In C there is no break outer. In C there is nothing called break outer, break inner, or something. Okay.
So we have to
No,
use
sir,
both.
he was talking about labels in C. Like if we put outer as a label before on the outer loop, then break outer breaks it from the
Yes,
outer.
that
That's
doesn't work in
Oh,
that doesn't
outer is a label. I see. This is go to. No. No, don't use go to like syntax. And I think break does not take any optional parameter like outer or something. This
yes,
is
sir,
not
it
like it.
doesn't. In C
But
and
of
C++,
course,
it
you
doesn't
can
work.
write go to label, and you can define label by label colon or something like that. But never again use your, I would say, use anything like go to. Break, continue, return, exit. These are like go to, but only these 4 things you use. Do not use explicit go tos. Never in your lifetime. Of course, unless you are using some other language where go to is necessity, like basic. But in C, C++, Java, and all these new high level programming languages, do not use go to. Okay. Because all over the world, people have, I would say, essentially discarded the use of go to. Do not use go to. Very bad programming practice. Go to is almost deprecated. Yes, go to is deprecated. So that's the question. And confusing. Maybe you can call it confusing, but anyway, it's okay. Is break used only in loops? Yeah, it's used mostly in loops, but you have seen that switch statement also supports breaks. Okay. Typically, it is used to
then
break.
so then one question, sir. If we suppose need to terminate the entire outer loop also, then what can we do if we don't use
One
the
possibility
labels and all?
is you set a flag here, come here, check that flag, write another break.
Okay, sir.
Okay. In fact, due to lack of time, I am unable to give you an example, but the slides posted, this actually demonstrates this. It sets a flag here before breaking, and I also want to break this, so I look at the flag value here and break. Another break statement. So in order to break both the loops, I need another break statement. 2 break statements I need. And that second is demonstrated by an example using a flag. Okay. So example, see the slides. Okay. If I got sufficient time, I would have covered it, but I have to start something about arrays and give you a demonstration of some small examples. So I prefer to skip this example. Okay, so maybe I can just load it and show you. Details you figure out from this slide. I think it's the 4th slide. Yeah. Third way. Oh, no. Actually, this flag is used for a different purpose. Okay. No, this is not exactly the example I am talking about. So maybe I just briefly explain you. You are trying to check whether n is a prime or not. So you start with I equal to 2 and you will go to square root of n. And if you see that n% I is equal to 0, then definitely you know this is a prime. Flag equal to 1. Okay. Oh, I see. There is only one while statement here. So this will actually break this while. I do not think there is an example in this, and I don't think there is an example in this. Okay. No. There is no example. With nested loops. Okay, let's see. If k% I equal to 0, breaks here. It does not break the outer loop, but is then, yeah. This is the example. So you have one for loop here, you have one while loop here. Before breaking, you are setting the flag to 1. Okay, that breaks the inner loop. And here also you check whether the flag is 1. Then you also break the outer loop. Okay, so you need 2 different break statements. This is for breaking the inner loop. This is for breaking the outer loop. And that may be conditioned on this flag value. Flag is initially 0, so if it is 0, it is not broken here. If it is 1, something is found. Then you want to break both the loops. So break and set flag, and then you take the value of flag and then break. Okay, yeah. So this example illustrates it. Okay, so you look at it. I do not have time to, cover every possible exercise example. So I will continue with our, where is it? Classes. 19. Okay. Okay. Fine. So next we will talk about arrays. Okay. So maybe I just have a 5 minutes break. Okay. Then we will restart. Okay, I'm back. Okay, so let us have a brief introduction to arrays. So we will do more about arrays later when we understand what pointers are. Okay, so let's say a user wants to input, let's say 100 integer values. So if you, without using arrays, want to do it, you may have to define something like n1, n2, n3, n4, n5, n6, and so on. And of course, not subscripts. Subscripts are not allowed. Let me delete. Or maybe it's easier this way. Okay. So n1, n2, n3. Keep on writing 100 things. That is extremely inconvenient, right? And if the user wants to enter, let's say 1000 values, so you have to declare something like 1000 integer variables. Okay. So this is very, very inconvenient. So of course you cannot do ... You have to write all the things up to n100, n99, n98, n97, everything you have to write. So this is, if nothing else, very inconvenient. Okay. So instead of doing this, I will say I have integer array with 100 elements. Okay. So these arrays are essentially, in a sense, homogeneous collections. Each element of the array must be of the same type. It may be an integer array, it may be a float array, it may be a double array. In fact, we will later see it could be an array of arrays, but these are difficult things. We will come to that much later in this course. Okay, so the general way of declaring arrays is you give the type. What type? Int, float, character, whatever. Then you give a name of the array. Then within a pair of square brackets, you write its size, as I have done here. The type is integers, the name is capital A, and the size is 100. Okay. So the question is then, this creates a memory sufficient to store 100 integer variables. So there are two things you must learn. Indexing in C is zero based, which means that if I consider this array, the elements are not A1 to A100, but A0 to A99, and this can be written like this.
Excuse me, sir.
Yeah.
Sir, you said this for A100, na? Matlab, for A100, it will be from 0 to 99.
0 to 99, yes.
Okay, sir.
Yes, yes, yes. Of course, this is for this example. And if I consider this example, it is name 0, name 1 up to name size -1. Okay. Of course, here you can use any expressions that evaluate to these values 0, 1, 2 up to 99. Okay. So it is not A1 to A100, it is A0 to A99, one less than the size. So this is one very important thing you must remember, and index values not in the desired range will not lead to compilation errors. Okay, so you can actually write 100, 1000, -50. These are all allowed. And if your code has things like this, and you compile the code, you will not encounter any compilation error. So the actual 100 integers are in these locations, A0, A1, A2 up to A99. A100 is actually outside this array, but you can access it, or you can try to access A100, A1000, A-50 even. Okay. And if you access these elements, there may two things which happen. So one possibility is get a garbage value. Because that is not part of the array, so something else is stored there or nothing is stored there, so you may get a garbage value. Another possibility is you may encounter segmentation fault. Okay. Neither the compiler nor the runtime system will ever check whether this index that you supply inside the square brackets, okay, is a valid index, valid with respect to the allocation size of the array. The compiler will not check. Even the runtime system, when you run, that will also not check. That will lead to, I would say, bad or even unexplainable consequences. Okay. It is the duty of only the user to ensure that whatever index it supplies while accessing array elements is within this allocation range. If it is not, this runtime system will try to return some value. It may be a garbage value, okay, storing something else, or it may even lead to segmentation fault. And I would say this introduces a lot of headaches while you program with arrays. Okay, it's a very difficult thing. Okay, and you will see many bugs arising out of this convention of C. Many other languages actually support range checks, but in C there is no range checking in arrays. Okay, so it is entirely your duty or my duty to ensure that whatever index I pass, okay, that is within the desired range. If I make errors, my program may be buggy. It may even terminate with segmentation fault. And a lot of other types of errors may happen. Okay, which you cannot imagine for the moment, but be very careful so that the indices that you pass are inside the range, inside your allocation range. If not, anything may happen to ruin your day. Okay, be very, very careful.
Excuse me, sir.
Yeah.
Sir, for array and for the variables which are there inside it, sir, the symbol is same. Like above we have written int A100 and A1,
Yeah.
A2.
So this is a declaration statement. Here it is defined by this kind of syntax: type, int, float, double, whatever. You give a name, a valid name, and within the square bracket size. So this is a special thing, right? This is a defining statement, whereas
Yes,
these are
sir.
accessing things. Okay. So
Yes.
Yeah. So maybe before giving you an example, I will tell you a little bit about the organization of an array inside your memory. Okay, so let us see.
Sir,
Tell.
sir, what is means segmentation fault?
Let us not worry too much about it, and just let us try to avoid it. Okay, I can.
So means will that raise an error message or something?
Nowhere you will get an error message. If segmentation fault happens, then the runtime system will say segmentation fault has occurred, and this program will terminate. That's what will happen. Okay.
Okay.
Okay. Compilation, no error. Runtime, no error unless you encounter a segmentation fault. Okay. So you have type name A, size let's say S. Okay. So let us say the size of this type, maybe int, is let's say k bytes. Okay. So then when you say this, a large chunk of memory is created. Large means, of course, as large as you suppose. So the supply is S. So the first location of this is something, maybe the start location. Let us call it L. L is the start location. Okay. The next location will be k bytes are needed to store this A0. So this is A0. This is A1. This is A2. And this is AS minus 1. Okay. The start location for A1 will be this k bytes are used. So the next location will be L plus k. This location will be L plus 2k. I will just demonstrate it by writing a code. And this will be L plus S minus 1 k. And the total size of this array will be S times k bytes. Okay, so I will just write a code to demonstrate that this is what happens. Okay. Also note that this AI, where I is in the valid range, is type, is a variable of type this type. Okay. So you can read, for example, if this type is int, you can read by %d, scan using %d, print using %d. Okay. So instead of writing N, I, J individual names, I can simply write A. So for example, I can have, maybe write somewhere else. Maybe the next page. I can have something like this. And AI. Okay, and I can also write print F %d %float A I B, J. Okay, where A is an array of ints, B is an array of floats. Okay, so you can use this individual array elements like integer variables or float variables depending upon the type of the array that you use for the definition. Okay, so when we have this construct, okay, we can do a lot of things, okay, as I demonstrate. Vi, let us say array dot c. Okay, so start with my morning prayers. Int a, let's say 100. Again, instead of 100, I can use a macro hash define size 100. Okay, int a 100. So that defines an integer array with 100 elements. That does not imply that I have to use all the 100 locations. Okay. So actually the user can additionally specify n, and I will use only n elements. Okay, sorry. I should use size. Okay, so once again, if this is my duty, C will not do. If n is greater than size, then you do some diagnostic message. You cannot have that big an array. And maybe once again you have exit 1 here. And if everything goes normally, exit 0. Okay. So now let us say what I do, I will use another variable I. Okay. Okay. So maybe here also I do something like this. N is less than equal to 0. Okay. N is less than equal to 0. Then of course, if n is less than equal to 0, I just say invalid size. Okay. So now I ensure that I will use some position of the array from 0 to n minus 1, but that will fit with respect to my allocation size. Okay. So note that this is entirely my duty to ensure that the user does not do something wrong. Okay. Okay, so I will now demonstrate something. Let us say I want to initialize A0 to AN minus 1. Okay, using some random values. And how big the random values are? Maybe they are 3-digit random values. Okay, something between 0 and 1999. So this rand function is defined in stdlib.h. Okay, so they actually returns an integer value between 0 and something called rand underscore max. Okay, anyway, let's see. And I want to I equal to 1, I less than n, plus I equal to I minus 1, plus
generates a random number.
Yes, it generates a random number. It's a basic, it's a library call, rand%5. So every time
Yes,
we
I wanted to ask, we also have random functions, other languages also. Here also, it prints something between 0 and 1, something like that.
No, you have to do, no. This rand is an integer. Rand, okay, let me write. Since I have used it, let me write. So rand returns a value between 0 to rand underscore max. Okay, in my compiler, this is 2 power 31 minus 1. Okay, so
got it.
If you want a real value between 0 and 1, for example, you define this by randmax and let it be a floating point division. Okay.
Yes.
Okay. Okay.
Why it is divided by percentage 1000?
No, because I do not want such 2 power 31 minus 1, such big things. Okay, let it be just small values. Random integers in the range 0 to 999. Okay. And then every time you increase by 0, 1, 2, 3, or 4. Okay, rand%5 is a value between 0 to 4, so you increase this. Okay, then I will just print I equal to 0, I less than n plus I. Okay, so I will show two things. First of all, a%d equal to %d and a %d equal to %p. I will explain. I, and AI. New line, yeah. Let us see, let us run, and then I will explain what it is to do. Array.c. Okay, so maybe although I am capable of storing 100 integers in this array, but the user will tell something like this. If the user says 200 invalid size, so it's once again you see that it is my duty to write a code so that I do not use an array of size 200 in a space which is sufficient to store only 100 elements. Okay, so it's my duty. Anyway, so let's say let me give it 10. Okay. So these are the random values that are assigned. 383, 384, 386, 387, 86, 89, and so on. Okay. And as I mentioned, if this beginning location is L, the next beginning location will be L plus K, the next one will be L plus 2K. And this beginning address is what is printed as a pointer. Okay. This AI, the address of AI is printed as a pointer. %p means print as a pointer. So how much is the size of one integer? It's 32-bit integers, right? So how many bytes? 32 bits means how many bytes? 4 bytes, right? So it prints this address in hexadecimal and increases this. For example, it is 80, 4 bytes are needed. So next starting address is 84, 88, then 812, 12 is C. And then another, then this is 90, 9. These are actually hexadecimal values. These are not integer values. Okay. So the different addresses you can see, right? Skipping 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes, and this is printed in hexadecimal. Okay. So, in fact, if I want a strictly increasing array, then I can simply say 1 plus, so that it is increased by at least 1. Anyway, this is not a huge issue. Maybe I give 25. Okay. So now A0 to A24 are used. The remaining 6 are not used. So this. So this is not correctly aligned. So what I will do, looks bad. Percent 2D, percent 2D. Fine. Okay. Now this is 40, 44, 48, 505. Okay. And these are increasing values. Is the difference is always 4? Okay, this question I will answer a little later. Is the difference always 4? This in this case, difference is 4 because int is of size 4 bytes. If I use double, the difference will be 8. If it is char, the difference will be 1. Yeah, it depends on the array data type. What is meant by a minus 50? Once again, look at this picture. What is meant by a minus 50? So if it is the ith element, what is the starting address? L plus I k. Okay. K is the size. 4 in our example. Okay. So now if I put I equal to minus 50, this will mean L minus 50k.
Sir, L plus I minus 1k should be.
No, ith one. I ranges from 0 to s minus 1. Put I equal to 0, it is a0. Same as L.
Sir, after L minus 50k? Sir, after L minus 50k, what?
Yeah, so if I say I equal to minus 50, this will be L minus 50k. Okay, so if I do these calculations here, L minus 50k will be some memory location. Yes or no? It's not inside this array, but somewhere else, somewhere here. And whatever integer sits there, that is a minus 50. Okay. This is this question. What is the meaning?
So, sir, any value will be returned?
Yeah, whatever is sitting there.
Okay.
It's a garbage value, maybe a garbage value, or if this is not in your permission, it will encounter a segmentation fault. Okay, so it's your duty 100%. You never access array elements outside the allocation range. Anything may be sitting there. In fact, this variable I may be sitting there. Okay, you do not have any control. What is there? Okay, so that's
Excuse me, sir.
Yeah.
Sir, is there any special significance of declaring the macro, or can we declare it as a constant variable also?
Yes, you can just use 100 here.
Okay.
No problem.
Okay.
I am just demonstrating how macros can be used.
Yes. So, but do they have any
Sir, can you
special
say once
purpose?
again what you say?
No. Two questions came together. I understood neither.
Sir,
So what did you say about macro? Can you say once again?
What?
Sir, what did you say about macro? Can you say once again?
Macro is some constant name. Okay. So this is just a name size which you have given, and its value is 100. So before the program actually gets compiled, the size, wherever this capital SIZE appears in the code, this will be replaced by 100. Okay. And then your program is compiled. Okay, so you don't need to worry about macros.
okay.
If you want to, if you write 100 here, 100 here, do it. No problem. Okay. Actually, it's not a good idea to use a variable here. Okay, although modern C compilers do support this, that is the reason I am doing something like constant, using its constant value, using a macro.
Yes, sir. So, a macro and a constant doesn't have any special difference other than a data
Constant,
type is different.
No, but this is a constant. So in this context, this is treated as an integer constant. Okay.
Sir,
Constant, if you want an unsigned thing, then you have to do something. Anyway, then let's not do about much of.
sir, can we declare characters also in the
Characters can also be used as macros. Any constant.
Sir, does C allow variable sized arrays?
The answer is yes and no. Let us not ask this question now. Okay.
Okay.
Okay. We will address this. The answer is yes and no. Okay, we will see later. Okay. So this is the organization of the array, individual accessing and all that stuff. But by doing this, what I have done, A0 to AN-1, this is now a sorted array. It's increasing, right? 383, 385, 388. Because I started with an initial random value of A0 and then I added something to it to get the next element. A1 will be A0 plus something. A2 will be A1 plus something and so on. Okay. And I would like not to.
Sir, 383, 387, what is representing?
These are some random values that I have assigned. What have I printed? AI I have printed, right? Okay, 20 or maybe 16. Let me work with 16. Okay, so some random values you are seeing, and these are the memory locations. There is only one problem here. Every time you run, you will get the same random values. And if you want to get different random values in different runs, you may do this. It is once again defined in stdlib.h. Just do this instead of understanding why you are doing it. Okay, this is needed for, so you see that every time you are getting 383, 385, 383, 385 and so on, but I want different things on different runs. So this is needed to different random values in different runs. So this is a way to achieve this and do it. This essentially says that seed, SWD seed, the random number generator using the current time. Okay. So if you run into different times, this random number generator will get two different seeds and therefore the sequence will be different. Beyond that, you don't need to understand anything. Okay, let's see. Now if I compile, I will get, oh, I see. Okay, it's a good thing that we use time, this time function includes type.h. Okay, this time function is not defined in stdio or stdlib, it's defined in time.h. Okay, now if I say 16, you see I am no longer getting 383. I make another run. Now 831. Okay. Okay. Anyway, so these are some useful tools. You don't need to worry too much about why it is like that. What now I will do, I will, as the last thing in today's code, in today's class, I will do some kind of non-trivial programming using arrays. Okay. So what you see here is a sorted array, integers. Okay. And I know that this is an array of size 10. So the indices are 0 through 9. And it may be deciding in an array of some declared size greater than or equal to 10. Okay. And I want to find out whether some element like 72 is in the array. Okay. Of course, here you can see it is in the array, but how will you in general solve this problem? So one possibility is one by one, I look at this until there is a match or until the array is exhausted. But if this array, there are too many questions here, there is dynamically defined array. Yeah, dynamic array. Let's not worry about dynamic array. This is supports n, but for the moment, let us not worry too much about this. It's preferable not to use variables here. Okay. Although the current compilers support it, provided n is defined. Okay, let's not worry about this. Okay, so 72. Okay, but I want a search, okay, which is more efficient than just by linearly searching from beginning to end. But I start with the assumption that the array is sorted. Okay, so let's see. So what it does, I use two indices L and R, left and right. Currently, my search window is the entire array, and I want to find out 72. Okay. So what I do, I compute the middle index, L plus R by 2. Okay. Now I compare this 72 with 37. Since this is a sorted array and since 72 is bigger than 37, then I am sure that there is no point searching for 72 in this part because this is a sorted array. Agree or not? 72, if at all present, cannot be in this part.
Yes, sir.
Okay, so I have to go to this part. So I will change L to M plus 1. P is larger than A4, therefore L is there. So my search window now have become an array of size 5 instead of an array of size 10. So this is my search window. Now once again, I compute the middle element. And of course, I can now say that 72 is there, but this program is written in slightly different way. Okay. Key is not larger. I am checking whether less than equal to or greater than. So there is no point searching it here. So I will move R from here to here. Okay. So the search window size now changes from 10 to 5 to 3. Okay. Once again, I compute the middle index. 60 is too small compared to 72. So there is no point searching it here. I will search in the upper half. So L now become M plus 1. L becomes R. And when L becomes equal to R, then I have essentially reduced the size of the search window to a single element. Okay. L equal to R, so I terminate the loop. And then I check whether this and this are same. Okay, they are same, and therefore I say key is found in the array. Now let us make an unsuccessful search. Search for 36. Yeah. 36. So once again I look at the middle element. Okay, so this is left, this is right. Okay. Middle. 36 is smaller, so there is no point searching here. Okay. So I will restrict here. Okay. Once again I compute the middle, 24. 24 is now smaller than 36, so there is no point searching here. So I will make L will go to M plus 1. Okay. Then once again compute the middle index. 3 plus 4 by 2. This happens to be 3.5, which is 3. Okay, 36 is larger. So L will come here. Okay. Now once again by a few iterations, I have reduced the size of the search window to only one cell. So I break the loop, L equal to R, loop terminated, comparing with key. Now there is no match. So key is not found in the array. Okay. This procedure is known as maybe I go to this procedure is known as binary search. Okay. So I will now write the code for this.
Excuse me, sir.
Tell.
Sir, but in when we were finding 72, then R was there at 72. So, like, why we can't also write something
I will
like
write
if
the code. I will write the code, and you will see.
Okay, sir.
Why? Okay. So the initialization was L equal to 0, R equal to N minus 1. And while L is less than R, I will continue. Keep on doing this. Okay, I will repeat this. What? I will compute the middle index. Okay. L plus R by 2. Key. What did I use? L plus 1 I have done. Less than a m. Else. Okay. Sorry. No. Greater than. If x is greater than am, x is greater than the middle element, then there is no point searching from L to m. So L will go to m plus 1. Otherwise, x is less than equal to m. So I set R equal to m. Okay. Now, if I want to check whether that 72 kind of thing is exactly here, then I require another if statement. Right. I could write if x is equal to am, then say found return break. Otherwise, R equal to m. I could have done it, but I am not doing it because I am avoiding two comparisons in this loop. Only one comparison. Okay. X is bigger than the middle element. Then I will search from the next element. Otherwise, I will restrict R to m. Okay. Then what will happen after this loop breaks? If L is equal to R, so I can simply check whether this is equal to this. Okay, this is a very simple-minded thing. Okay, then what is the value of x? Okay, user supplies X, and then I do this binary search, and then I simply say, oops. 16. Now the user asks for, so you give me a value somewhere here, maybe 944. He found. Okay. Maybe again I give 16. And this time let us give some value, maybe 483. He not found. Okay. So in order to see that how this algorithm is very, very efficient, let me do one thing. I use a slightly bigger array. 1, 2, 3, 4, 5, 10 power 5. I hope I can. Okay, I can do this. But I do something. Okay, maybe. L to R, what is the size? R minus L plus 1. After this reduction, I have window size this. Let us see how the window changes. But now I can use much bigger arrays. Okay, the initial part, it's still taking too much time. So anything like that. Okay, maybe this. Okay. So initial size is this. It is halved, 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 so on. Eventually, the window size is this. And then the final comparison fails. Therefore, this is an unsuccessful search. Maybe. Hopefully this is there this time. No, this is also not. He found. Okay. Okay. So you see that I start with a pretty big array, 100,000. In one iteration, I reduce the window size to 50,000. Then in the next iteration, 25,000, and so on. So every time I am essentially reducing the size of the search window to half, roughly. Okay. So if there are n elements in the array, how many iterations will this binary search take?
Log
Log n,
Log
right?
2.
Log 2n.
sorry log n, yes.
Therefore, this binary search is very, very efficient. Okay. But then I need a sorted array. Of course, it makes very little sense to run binary search in a non-sorted array. Okay, maybe I stop here. I will upload this code and the other code to the course website. So, but I hope that you now have some familiarity with arrays and what is log 2n? Log of n to the base 2?
No, sir, means how you derived that?
This is actually approximately. Okay, because you see that if you look at the general case, I am considering the mid index. Where did I do it? Yeah, left index plus right index by 2. And then I am throwing either the left half or the right half. Okay. So half of the array is thrown. Remaining half I am working on. Okay, so every time you are reducing the size by a factor of 2. So after log 2 of n iterations, this will eventually boil down to a window of size 1. Right. And why approximately? Because if a size like this, if you see a size like this, 49 is not even, so you cannot evenly break it into equal parts. So this part may be bigger. And here, of course, this is smaller than 13 by 2. Okay. Okay. So that's the reason.
Hello, sir.
Yeah.
Sir, is it possible to determine the execution time of any program?
Of course it is.
Sir, if so, we can determine that, then we can find the efficiency of conventional linear search and then binary search.
Of course. Yeah, you can do it practically. And this is what is called a theoretical measure. So we have, I am telling that log iterations are necessary. And if we have some time in the end, I will formally introduce the notion of efficiency, running time, time complexity, things like that. Okay.
Okay.
Yeah. This is the worst case. And of course, if I could, if I checked for equality also here, this is another code, but that requires 2 comparisons. And on an average, this will be, I would say, of the same complexity. But if it is quickly located, then this loop will break. Anyway, let's not worry too much about that. Let us work on this version. Okay. Yeah, so you have seen some non-trivial examples of arrays, and binary search is one of the very useful algorithms for computer science, and similar techniques can be used for a lot of problems, not just for searching in a sorted array. Anyway, so let me stop the class now. It's already past 5. Let me now answer your questions if you have any.
Sir, what will be the pattern or syllabus of short test 1?
Look, we have not yet decided that very concretely. Maybe a few multiple choice things, plus you may be asked to write a few small codes. We have not yet decided, but this is broad, I would say, broad guidance. Yeah.
Excuse me, sir.
Hmm.
Sir, in finding in binary search, I didn't understand one point. If we have L and R and we are finding M, and after that, if let us say M is less than the number, then we are shifting L to M or L to M plus 1.
L to M plus 1 or R to M? Not L. If X is bigger than AM,
yes,
then
sir.
Starting from AL to AM, X cannot be there. X is already bigger than the middle part. So the
Yes.
left part of the window, I am moving to 1 more than M. Otherwise, X is less than equal to AM. I am not yet checking equality immediately.
Yes,
okay.
Sir.
So in that case, there is no point searching on the upper part. So, but it may still be M. So I am setting R equal to M.
Yes, sir.
Okay.
Yes, sir.
Or if you make it a 3-way comparison, if you get an exact match here, then you break the loop and simply say, this will also work, but you will require 2 comparisons in each iteration of the loop. I am doing only 1 comparison.
Sir, and what will happen if x is equal to am?
Equal to means less than equal to also.
Yes, sir.
Okay.
Yeah. So hence it will go in that case.
It will go to that case.
Yes, sir.
But then you should not discard m, because equality is possible here, right?
Yes,
That's why it's not m minus 1. It's
yes,
m.
sir.
Okay. Yeah. That's it.
Sir, what will be the syllabus of the PDS test?
So what will be the syllabus? Oh, okay.
I think up to arrays. Next we will start functions. If possible, tomorrow I will start functions, but functions will not be in the syllabus.
So how will it be? Like it will be objective. Like what will be the way of or pattern of the test?
No, that's what I mentioned. It may be a multiple choice. I give you a code. What is the output? That kind of stuff. Or which one is the correct program for this algorithm, something like that. Or you may be asked to write some small codes, 5 to 10 lines of codes. Okay. Given the problem and given the problem and the algorithm explicitly stated, you just code it. We will not ask you to design an algorithm. That's not a part of this course. Okay.
Sir, for predict the output, one can just use an editor, right? Like we will have editors with us.
Or?
No, sir, nothing.
Yeah, actually, we have created Moodle accounts, the Institute Moodle. This detailed instructions will follow sometime in this week. Yeah.
Sir, I have a doubt, sir.
Yeah,
in case of define macro, is it only for integers or can we use it for characters and strings as well?
Any constant.
Okay, so wherever that word occurs in the program, that will be replaced by the next means integer or character.
Exactly. In fact, macros have a lot of problems, so we don't want to introduce at this level. Okay. Instead of just constants, you can have expressions and other things there. You can even have parameterized macros. So macros are not exactly function calls, but let us use macros as constants for the time being. If time permits, later we will talk more about macros. Okay. Yeah.
Okay, sir.
If time permits.
Excuse me, sir.
Yeah.
Sir, can we find number of digits in factorial?
We can. Of course we can. Maybe it's not a bad thing. I actually show you something. 100 factorial. It's this number. 1000 factorial. It is exactly this number. So these are the number of zeros. Okay. But in C, of course, you cannot write this code straight away because this is a multiple precision calculator. But you can use this formula. I'll give you the formula. Okay. Number of.
Sir, we knew a formula during JE time for calculating this.
What is the formula? Is this?
For any number divided by 5 and box function. And 5 to the power लेना पड़ता था.
0 to infinity it may be, but
So like n divided by 5 to the power 1 box plus n divided by 5 square, and this will continue till it becomes 0.
The only thing I made a mistake. I'm not starting from 0. I'm starting from 1. Yeah. So it's n by 5 plus actually n by 5 by 5, but this is basically same
Excuse me,
as
sir. Number of digits, not zeros. Number of digits in n factorial.
oh, number of digits. Number of digits. One possibility is what is n factorial? Take log to some base, maybe 10, because you are talking about decimal digits. The summation log I equal to 1 to n. Okay, so you can compute this. There is a math function log 10. As far as I remember, log 10, there is a math function, library function. Then add up from 1 to n. From that, you can take the integer value. That will give you the number of digits. Happy or not?
Yes, sir. Yes, sir. Thank you.
Okay. So whatever you get, plus 1. Okay. That integer part plus 1. Yeah. So it's interesting to write small codes for these things. Okay. Yeah, tell.
Sir, can you please show how to find the execution time of a program?
No, let us not do right now. Let us wait.
Okay, sir.
So there are lots of things I cannot teach everything now. Okay.
Okay, sir.
Okay. Yeah. Yeah. So any other question? Okay. If there are no questions, then let us stop. See you again tomorrow. We will continue with arrays, and if time permits, I will introduce functions.
Thank you, sir.
Thank you, sir.
Okay, thanks for joining.
Thank you, sir.
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 Thank you, sir.